Hello, everyone. Thank you all for coming to the talk. I'm going to be talking about how at IO Interactive we're creating believable NPCs in our AAA games. So the agenda for today, I'm going to give you some problem statements, a few videos to showcase some issues that we have on our NPCs, and essentially just explain and give you some overview over what the talk is going to be mainly about. After that, we're going to jump into some context into how us AI programmers are programming the behaviors for our NPCs, how they're making the decisions and selecting which behaviors are the best suitable ones for the world state. And then we jumped into the two main themes of the talk, that being animation entries, so moving to perform an animation, and then also context-sensitive animation exits, and that's like, how do we make our NPCs that need to exit animations look really cool and like they know what they're doing. And after that, that's about it for the talk. I'm going to wrap it up and just give you an overview of some future work that we have planned to implement. I am Vasco Magalhães Pereira. I have a master's degree in computer science. I've been at IO Interactive for about a year. I joined at the start of the year. Before that, I was at Rockstar for 2 years. So if you do the math, I've only been here for 3 years in the game development industry. So yeah, not a lot. And before that, I was working on some mobile games. And I must say that when I transitioned to the AAA game industry, and I don't have any experience on indie dev, but when I transitioned to AAA, there's like a big push and a big expectation from the players to have and meet really high quality for anything that they see in the game. And for us AI programmers, that includes all NPCs feeling real, and they're all gameplay circumstances that we put them through. So at IO Interactive, us AI programmers, animation programmers, and also our animators, that's exactly what we're trying to do. So in the talk, I'm just going to give you an overview of some techniques that we've developed in the last few months for our games. And these are the two main topics of the talk today. If we can look at the top video, there's showcasing an NPC moving along a path across a wall. And then when he gets to the end of the wall, we kind of want them to perform an animation. But yeah, if you can notice, they have a bit of a jittery movement, a bit glitchy when they go from the transition from locomotion to the animation. And that is because the pose does not really match accurately. And the only solution that we had at the time was to have a stop and start behavior. So the NPC would essentially just walk towards the destination, stop, and then start playing the animation from idle. But that, again, does not lead us any closer to our goal of having them feel believable, because it just looks too robotic. So yeah, hopefully we're going to be able to fix this during the talk. And then on the bottom video, we see an NPC is playing an animation act where he's sitting down. And because of gameplay reasons, we need them to be able to exit these animation acts as fast as possible, because, for example, there's something that they need to react to, so they cannot keep sitting down. But I mean, I think we all can see that he's getting up unrealistically fast. There's just no good way to handle it. And the only way we had it was to really just wait for the animation to finish until we could adopt the behavior to react, but then they would just be really slow and does not communicate any behavior, any intention, any like emotions towards what is happening around them. Having said, I clicked the wrong button again. Having said that, let's jump into the decision-making of our NPCs and how us AI programmers are creating these behaviors and how we issue commands to the NPCs and so on what. We're using something called a Hierarchical Task Network, HTN for short. And for us, our HTNs for our games just look like much bigger scaled up versions of the graph that we have right here. It's just that it's much easier to explain and go over how this all works in this like small graph. And the main point of the HTN is to find the highest priority behavior that suits our needs, suits our conditions. And yeah, we will traverse it by a depth-first approach, and that essentially means that we want to go as deep as possible into the network before we go down. So that means that we will start at the first main method on the left. There's 2 branches on that method, therefore we select the top branch because that's the higher priority branch. And within that branch we see that there's 2 methods, and again we select the first one, so we always go deep first until we get to the task at the top. And we always are checking whether the conditions are met for us to keep going deep, or if we should just skip the whole part of the network. And the whole goal of the HCN is to then find a plan, and these are our behaviors, that the NPCs are going to execute. This is done through composing tasks into our plans. The way the plans get composed is by traversing a branch that communicates to us that it wants to begin a plan, and then we traverse the whole network that's called within that branch. So if we see the highlighted branch on the slide here, first we go to the top method and we find those 2 tasks over there. All the conditions are met, therefore we add them to our plan, and then we jump to the bottom method. The first branch is kind of grayed out, so just to communicate that something failed. Well, this is not a good branch, so then we go to the bottom branch. There's no tasks, so at the end of the day, our plan and our behavior is only made up of those 2 first tasks. And you can see that with this, we can kind of create a lot of variations of the same behavior, depending on the conditions of the world and the awareness of the NPC. And then lastly, there are 2 ways to finish our plans. The first one is to succeed that plan, so we finish all the tasks, everything went according to plan, and then we just need to find a new plan, a new behavior to execute. Otherwise, we probably have a higher priority plan to execute, so we just need to abort the old one, handle all the abort conditions, how do we want to proceed now, and adopt the new behavior. It can also happen that the conditions to keep executing our plan are no longer met. At that point, we also abort the plan and adopt whatever new plan that we found along the way. Oh, God. And the main method, the main way we traverse our network is through methods, and they sort of work like function calls to us. They receive arguments, and they can be called from anywhere in the network, and they are composed by a set of branches. So each method can have as many branches as we want. A branch is, I think we can think of a branch essentially as an if statement that has some execution blocks within it. So it's composed by a condition block and a task block. The condition block will essentially check whether the conditions are true or are good for us to keep going down into this branch. And then the task block is essentially the connections that we see here on the graph. So it can call a method, it can also start a plan, and it can execute tasks. There is also another special type of branch, and this is the one we use for maintaining the execution of our behaviors. So these are separate conditions that we can have that will let us know whether or not we should maintain executing a plan that we are currently running. So if we think about the NPC that we had that was sitting down and that had to be interrupted because of something in the world happening, in that case, we have a higher priority behavior, so a higher priority branch that got adopted because the conditions were true. But before that, there was a validation branch saying like, okay, you should keep sitting down because this is a good behavior for you to execute right now and there's no need to do something else. And then finally, on our network, we have the leaf nodes, and these are our tasks. These are the things that we actually see the NPCs executing, like moving along a path or performing an animation, looking at certain positions. So this essentially is what controls the behaviors of our NPCs. And hopefully, these are the only things that at the end of the day get composed into the plan. And this is the end result of every frame whenever we update and go through the network for each of our NPCs. We end up with a composed plan, and so we always know which set of tasks do we need to execute. The tasks can be blocking, so we can have tasks that take multiple frames to execute. At that point, he will just let us know, keep waiting. That means that we will not progress to other tasks in the plan, but we also have like tasks that just succeed or fail immediately, and if they fail, we also abort the plan. Just want to give some special attention to this empty branch that we have here on our highlighted plan. That empty branch is kind of a pattern that we came up with and we use quite a lot, and that's basically a fallback branch for methods where we want to communicate that we're just trying to do something. So let's try to execute this task, but if the conditions are not true or if the task is not able to execute, it's okay. Let's just not add anything, but we don't want the method to fail. So the fallback branch will always succeed for us. And yeah, I think with that, hopefully we have enough context so that we can now actually jump into the problems on the presentation. First of which being, how do we handle our NPCs moving towards a destination to then play an animation act? Okay, just to recap a bit, and looking at the video, we can see our NPC and is walking towards the destination, and then at that point we want to play an animation act, but we see that there's a bit of a jittery movement because, yeah, the poses do not match, and the behavior just doesn't look natural at all. So what are the new requirements that we want for whatever system we come up with? First of all, we want to reduce as much as possible all the stop and start behaviors. It is not suitable for us to most of the time just have an NPC go towards the destination, give a little pause so that the pose matches an idle pose of the animation act. That is not good. That does not communicate like an alive NPC. That's just too robotic. The other thing, yeah, we want to get rid of these unnatural looking blends. They don't look good. And finally, we want to minimize foot sliding because again, foot sliding, if seen a lot across the game, can take the player out of the experience. How do we address the first requirement? If we look at the video, now we have an NPC walking through what looks like are multiple paths just to get to the destination and do the same thing. It's just that this time he is actually pausing, but because the animation was not built for an idle pose, it still looks odd and is still a glitchy movement. And this is mainly due because on our plan we used to have move along path and a perform animation act as separate tasks. So there was no way to communicate this context to the move along path, that after the end we want to perform an animation act, so please don't pause and don't go into idle when you're executing. The way we solve this is we kind of just now have two tasks, we have one merge task, which just goes move along a path to perform an animation act at the end, and it receives our animation and it receives the animation parameters, but the path as well as our arguments. This kind of is the thing that we were seeing in the previous videos. It still leads to the unnatural looking blends, but at least they're not pausing at the end of our paths. And then to kind of get away and like not have these pauses along the path of our NPCs, I think many of you may know what this is, but instead of having a single multiple paths from A to B, from B to C, and what looks like here from C to D, we have a single path and just have B and C points as waypoints on our path, and that the Pathfinder will just sort of calculate A to B, B to C, but it will append those paths together, and the motion will be smooth because it's all running on a single task. So that just got rid of the whole weird looking poses. But now we do have the unnatural blends. Yeah, they don't look great. This is because or not because, but some context is that our NPCs, the way they play animation clips and even the locomotion and everything that they're doing, that's placed on an animation graph. So every NPC will have a gigantic animation graph of all the animations that they can execute. And we will select the proper animation clip because we have arguments on this massive graph that will help us select the right clip for every frame that we are executing. The problem with this is that all our animation acts used to be on this massive graph as well. But the good thing is that our animation programmers, they did a lovely job, and we started moving away from having the animation graphs on the animation acts on the graph itself, but we have them as separate networks that we can then inject into the graph at certain points in the game. So like here, we injected the animation act, and then it starts playing an animation. That animation act, the network, does not need to be on the massive animation graph of the NPC. A few things that really are good about this is, for one, we can create the network ahead of time without the need to inject it into the animation graph. So what we do is we grab our animation network, we create it ahead of time while we're doing the locomotion, and we can query which is the starting pose that we want to achieve. How do we want to get to the destination so that we will match the same pose as our animation. And then there's also that the animation parameters are specific to this injecting network itself, so we don't need to have all of our animation parameters affecting the whole graph at the same time, because the parameters can be set for the network itself, and that also helps us query the starting pose ahead of time, because then we can just traverse this network with our parameters, and we will select the right animation clip, and then with that we just have the starting pose. And then, again, our beautiful anim tech team, they're awesome at preparing the body to arrive at the destination of our path, if given enough time to match the starting pose of the animation, so that we can have a beautiful looking blend where the seams are not visible and everything looks nice. There is a few constraints on this, though. For one, the distance to the destination cannot be too short. If it's too short, the animation will not be able to match the destination, or we will see a lot of pushing and pulling of the animation of the NPCs, so that they can slow down quite a lot, and then a lot of foot sliding will be happening, because there's no way for them to arrive at the destination with a realistic looking set of animations. So what we do is, on our HCN, if we detect that a path is too short for us to perform an animation at the end, we just sort of don't do that animation. We select like a different behavior as a fallback, and it sort of helps us quite a lot. I think having this, we can now look at the final results. This is all work in progress, please. But yeah, it already looks much better, I think. And yeah, don't ever mind the guy at the back. He's our quality assurance agent. Yeah, and we can see there's still some foot sliding here and there, and the poses don't exactly match sometimes, but with better content on these animations, and with a bit more tweaking here and there, it can get to a much better state. And even from the previous slides, this is already a much better improvement. And then finally, I think we can jump into the context-sensitive animation exits. And these are a tricky one. So what do we have here? We have an NPC, and we want him to play an animation. But when we kind of abort this behavior and we want to adopt some new behavior with a new set of tasks to execute, not always are we able to just start playing those new tasks right away. So a few requirements that we need. We need fast exits out of these animation acts. We need the NPCs to be able to react to stuff that is happening around the world, and we need them to just get out of this state as fast as possible. The second one is we want animators to be able to play bespoke animation exits. If they create an animation act that is very unique, it shouldn't require coders to do any more work. They should be able to express themselves and have these exits whenever they need, so they don't get blocked by coders. And then finally, obviously, we want them to look believable, and the most important, I think, is we want them to look appropriate. What this means, essentially, is we want to, while they're playing an animation exit, we want their body language and we want their motions to already communicate what is the new state they are transitioning into. So the way we add this, and the reason why they look so bad, is essentially because this is all gameplay driven, okay? And we are only as good as it can get without the help of our animators. So all these transitions, this is all gameplay driven, this is all handled in code. And essentially what we add is this massive list of what we call an environmental lock. An environmental lock is essentially anything where the NPC is in a position where he cannot instantly go into, for example, a move along path. Like he needs to get out of his state so that he can do anything. And this is like what we saw the animation where he's sitting down in a chair. In this one, he's leaning to what looks like investigate something, but it can be a lot of things like leaning against the wall. And I mean, I think you can already tell as well that for a project agnostic solution, the gameplay scenarios and the variance of these environmental interactions can grow exponentially without a lot of visibility, either for the animators or for us. But the truth is, it would always require some coder support for us to be able to transition from these locks, either to other locks or to outside of, to be in an unlocked state. Yeah, they just don't look really nice. It's just too fast, and it doesn't communicate anything to the player. Our new system will then involve moving all of our animation acts into Injecting Networks. This is important because we don't want to, when sending animation parameters to the new to our new animation exits, we don't want it to interfere with the whole animation graph. We want to have very bespoke animation parameters that can control the exit itself without having to interfere with everything. But in general, it also makes it a lot easier for our animators to work with these networks. Having them in Injecting Networks also allows our animators to create generic exits for some of the acts, and if two acts are very similar to each other, so we have two different acts where the NPC is sitting on a chair, they can just share the same exit, and they will just create one single block, and if they need any changes, it will just replicate to all the animations that share this same animation exit. And that is quite helpful. And on our end, on the AI side, and also on the gameplay side, all we need to do is essentially just wait for an animation act to an animation act event to be sent to us. So if we look at this NPC and is performing an animation act and is leaning against a wall, at the point where we want to abort, this means that our plan got aborted and we want to adopt a new behavior. When this happens, all we need to do is that we just send a parameter to the animation that is playing saying that we need to abort, and then that parameter will be handled internally on the Injecting network to start playing an animation exit. And a few benefits come from this approach. For one, everything is animation driven. It doesn't require any AI or gameplay code to be implemented, so animators are very free and very unblocked from us being slow to implement stuff. So it empowers animators to create the best looking exits for each animation. This means that if they have a very unique animation exit, they can just create a bespoke exit for that one, and it'll look great for that one animation act. But it also means that they can share these exits, and it doesn't require anything from us. And then I think the most important here is that we now have parameters to control how our animation exits are looking. So there's a few things that we can do. For example, we can control how fast we want the animation exits to look. So if it's a very casual situation, we can exit very slowly, because during the exits, they already kind of communicate that they're reacting to something, so it's okay. But if they need to exit as fast as possible, we can also do that. There's also we can set a new locomotion style, so they can either exit into combat, and during the exit they already raise their fist and they go into action, or they can have a casual exit. And then we can also send, for example, an act direction. So during the exit itself, they already exit our animation looking at a certain way. So if we're interacting with a table or something and something happens behind us, we just go like, what is happening? But our current solution would just require us to get up and then look. And this leads to a lot of robotic behaviors, which doesn't look really nice. And yeah, AI code was simplified. Hooray. I think we did our job. And this is the final result of the animation exits. All that we are seeing are the exits themselves. So at the point where they get into their animation, something is played in the world and they need to react to it. And you can already tell that their body language kind of communicates to the player what is happening. So even if the animation is quite slow and the exits take their time, because within the exit is already embedded some body language, it's already embedded some communication and some context, it's okay to have them a bit slowed down. The one thing we don't have here is like different locomotion styles, because those can get pretty project specific, and I just wanted to highlight the project agnostic solutions. I think that is it. Just jump into some future work. For one, we want to improve the use of both full body and upper body animation acts. So that means that on our HCN, we'd be able to play an upper body on top of a full body animation. But also, we'd be able to have animation acts that have mixed approaches. So at some points in the animation itself, we can have either full body authority or just upper body authority. And the good thing about the upper body authority is that it sort of gives us control over the legs, so we can walk and we can face positions, so AI can control lots of cool things. And then the other thing, and it's kind of similar, is control over the look at. So right now, animation network and AI is kind of fighting over control of the look at. So we need a good way for animation to be able to communicate to us that they want to control the look at position, and then just kind of give it away to us whenever they're free to do so. And just generally just creating new tasks and kind of merging our behaviors so that we have fluid behaviors. And another thing is like just better looking transitions from behaviors. Those are the points essentially where our NPCs can look very robotic, because these transitions, if visible to the player, they just kind of communicate that there is an AI, there's like a program running in the background that controls these NPCs. And so if we're able to hide that and blend it away, that would be great. Thank you so much for attending the talk. I think it's short on time, but yeah.